Hello students, today we are going to discuss a very interesting problem which has come in JEE Advance 2025. In this problem actually, he has taken a cylinder and as you can see in the figure on the left side, he has cut a plane and that plane length is L which is matching with the cylinder length actually. It's a hollow cylinder and whose internal and external radiuses are given. And if you see the plan on the right side, there is a plan cut has been made where from A to D one section has been shown. So you have to find out basically what is the electric flux which is going through the plane actually. The thing here is the outside of the shell is potential is made zero. Only on the inner surface charge Q is there. So how do you approach this problem means basically if you go by the standard approach, you have to take an element between A to B and C to D. Okay, one challenge here would be because here electric field is radial actually. In the BC part, because it is a shell, so inside there is no electric field. That means there is no electric field, means there is no flux lines also which are going through. So that part you can ignore it. So I can say that the total flux, it will be flux in the AB part, flux in the BC part, and flux in the CD part. Flux in the BC part will be equal to 0. The standard approach will be take an element between A to B, and by symmetry, CD portion also will contribute the same number of lines. Here we are assuming that the plane cut that has been made is sufficiently long. Okay. Now, if you take an element, we have to crack the geometry first, and we will apply this elemental flux will be E multiplied by the elemental area ds. As you can see here, this E is in the radial direction. That means it will have two components, one in the horizontal direction and one in the vertical direction. Because you are considering two sections, one is AB and one is CD, the vertical components will be cancelling each other and only the horizontal component will survive. So if you do the basic maths, first we'll find the d phi and we'll integrate it. So for d phi, we are using basically the formula for that line element. Okay, if I have to explain that, uh, see, basically you're finding that line element one formula is there, no? That formula we're going to use. Let me draw that here. You might have studied this in your class. So if the point of consideration is this is the line element I'm considering, so there is a formula for that actually. So that formula we can use, and that formula basically is this. Okay, cos theta we are considering because only horizontal component will survive, and small r is the distance between the point of consideration to the element considered, and lambda is the charge density. K is 1 by 4 pi epsilon naught. So if you do your basic maths, you do the integration, finally you can crack this using the trigonometric ratios cos theta and sin theta, and there you have to solve for this dy, and once you integrate it, finally you'll come to an answer which is flux of AB is equal to Q by 120 epsilon naught. Here actually this shell is kept with a dielectric whose value is 5. If you read the question, the ER value, ER epsilon R which I call it, is given as 5. So in the denominator when you are multiplying the epsilon naught, no, you have to multiply with the dielectric constant also, so that 5 value will come over there. So finally you will get Q by 120 epsilon naught. But because there are 2 multiplied by 2, you'll get finally Q by 60 epsilon naught, which is the answer. However, there is an alternate approach also. And what is that approach means? We can calculate the angular spread. Here you can see, as I have shown in the diagram, the point O, we can find out this angle AOB. So total angle is 60 minus 45, it is 15 degrees. Now I can directly apply Gauss law, which states that flux is equal to Q enclosed divided by epsilon naught. Okay, why I multiplied with epsilon r means because there is a dielectric over there. Now here we are not considering the entire flux, we are considering only a small portion, so we have to consider the proportionate value. So what will be the proportionate value means it will be 15 divided by 360 into 2. 2 means because we are considering the other part also. Now why I divided by 360 means you can see that that blue line, if you rotate, no, the complete angle will be 2 by radians. Okay, so you're considering only the 15 degree part, so proportionate flux will go. So if you calculate like this, you can very quickly come to the answer which is q by 6 I by epsilon naught. Only proportionate value have to be should be considered over here. Okay, if you like more this type of stuff, you can comment in the comment section. I will be regularly posting this JEE Advanced questions with an alternative approach. Thank you.